Hello and welcome to Dr. Anima Upadhyay's Chemistry Lab videos. In today's video, we will learn the important Vivoc questions and their answers on the topic Determination of Aluminium with EDTA method using Xylenol orange as indicator. This video I am making on special request from many students which I received in past few days. After they watched my video on the determination of aluminium with EDTA back titration method using Arichrome black tea as indicator, many of them approached me and requested to me to make a video with Xylenol orange as indicator. So here I am with their topic of interest. If you have not subscribed to my channel so far, please do it and also share this video among your friends and colleagues. Now let us begin with today's topic. If you are given an ore sample for the determination of metal in it, the very first question that could be put to you by the examiner is, what is an ore? And you should answer that an ore is a mineral from which metal can be extracted economically and profitably. What is a mineral? Minerals are the natural inorganic substances in the earth's crust with a combination of elements. Explain the statement that all ores are minerals but all minerals are not ores. And is this a true statement? Yes, it is true that all ores are minerals but all minerals are not ores, because the compounds with even traces of metals present in it from which the metals cannot be extracted are called minerals. But ores are the compounds or minerals which have sufficient high concentration of metal and they can be extracted from the minerals commercially at a large scale. So the statement that all ores are minerals but all minerals are not ores is absolutely true. In which ores aluminium can be determined and what should be the concentration of the metal in the ore? Aluminium can be determined in iron ores, in concentrates, agglomerates, and the concentration range of aluminium in these should be in the range of 0.25 to 5%. Why iron should be removed before the determination of the metal and how it is removed? Iron interferes with the analysis of aluminium. Therefore, it should be removed by extraction method using MIBK. Expand MIBK, or what is the full form of MIBK? The full form of MIBK is methyl isobutyl ketone. For removal of iron, what type of medium is required for its extraction in MIBK? In acidic medium using hydrochloric acid, iron is extracted using MIBK. Is there any other method to separate iron from the analyte? Yes, we can use an alternate method where we reduce iron 3 to iron 2 using ascorbic acid as reducing agent to minimize its extraction into MIBK so that the analyte may be isolated by extraction and the element of interest is then determined using the aqueous solution. What are the impurities present in the ores and needed to be removed in the process? The impurities are organic matter which should be destroyed using nitric acid and hydrogen peroxide prior to the removal of iron. What are the indicators employed in this method? The indicators used are methyl red and Xylenol orange in this method. Is this a direct method for determination of aluminium using EDTA? No, it is not a direct method, but a back titration method as discussed in one of my videos. So please refer that video. I will give the details and the link of that video in the description box. What are the reagents required in the method? The reagents required are ore sample, MIBK, hydrochloric acid 0.1 normal, HNO3, nitric acid, hydrogen peroxide, H2O2, ammonia, sodium hydroxide 10%, EDTA solution, standard zinc ion solution, ammonium acetate solid, ammonium fluoride solution, and the indicators methyl red and xylenol orange. What are the equipment required to perform the analysis? The equipment required are electronic balance, glass beaker, hot plate, conical flask, volumetric flask, burette, pipette, funnel and Whatman filter paper number 41. What is the principle of the method? The principle of the method is that the ore sample is fused with flux of sodium carbonate and sodium peroxide in a zirconium crucible. It is then dissolved in dilute hydrochloric acid. The oxides of the metal are precipitated as hydroxides with ammonia after destroying the organic matter with nitric acid and hydrogen peroxide. Iron and titanium are removed by MIBK extraction and the aqueous phase is then treated with nitric acid and perchloric acid and evaporated to dryness. The evaporated mass is then dissolved in dilute hydrochloric acid and filtered. The filtrate is treated with excess EDTA and the unreacted EDTA is titrated against standard zinc ion solution using xylenol orange as indicator, to which ammonium fluoride is added to release the EDTA which is bound to the aluminium, and the titration of this released EDTA is continued with the standard zinc ion solution, and the aluminium in the ore is then calculated in the terms of percentage. Is there any other reagent in place of MIBK that can be used for removal of iron and titanium? Yes, we can use cupferron and chloroform in place of MIBK. What is cupferron and what is its formula? Cupferron is N-nitroso N-phenyl hydroxylamine. It is a common reagent for the complexation of metal ions and its formula is NH4C6H5N within small bracket O NO. Can you give the brief procedure for the determination of aluminium in the ore sample in the lab? The steps involved for the determination of aluminium in the lab are that we should start with weighing around 1 gram of the ore sample after removing the siliceous impurities. Fuse the residue in sodium hydroxide and make the volume to 500 ml in a volumetric flask using distilled water. Pipette out 50 ml of this stock solution, to which add sodium hydroxide solution 10% and precipitate the metal oxides into hydroxides. Heat it on a hot plate to ensure complete precipitation of oxides into hydroxides. Cool it and filter it using Whatman filter paper number 41. To the filtrate add EDTA solution around 25 ml followed by 3 to 4 drops of methyl red indicator. Add 1:1 hydrochloric acid dropwise to pink end point to neutralize the sodium hydroxide, that is the alkali in the solution. Add 2 to 3 grams of ammonium acetate to make it slightly ammonical, and this is ensured by the change in color from pink colored when pink color changes to yellow. Bring to a boil. Cool it down to room temperature and add 6 drops of xylenol orange indicator. Titrate the unreacted EDTA with standard zinc ion solution till the pink end point is reached. Record it as titer value 1, T1. Now add 15 ml of ammonium fluoride to the solution to release the EDTA from the aluminium EDTA complex. Heat to a boil for about 5 minutes. Cool and add 1 gram of ammonium acetate. Continue the titration with zinc ions and xylenol orange to pink end point. Record the purity reading as titer value 2, that is T2. Run a blank solution, that is standard EDTA solution with zinc ions, and obtain a total titer value, that is capital T. Now the difference between T and the sum of T1 and T2 gives the quantity of aluminium present in the ore sample. Repeat the complete procedure using standard SRM sample or CRM sample. What is the role of methyl red indicator? It confirms the neutralization of the alkaline analyte into acid. The change of color to pink red from golden yellow ensures complete neutralization. What is the role of addition of ammonium acetate? Addition of ammonium acetate adjusts the pH to around 5.4, which is suitable for aluminium to form complex with EDTA. Why ammonium fluoride is added to the solution? Ammonium fluoride is added to release the EDTA which is bound to aluminium. This unbound EDTA is then back titrated with the standard zinc solution and the percentage of aluminium is calculated. Is this method an example of back titration method? Yes, it is a back titration method for the determination of aluminium. Can zinc solution be substituted with some other solution? Yes, standard lead nitrate solution can be used in place of standard zinc ion solution. What is the formula employed for the calculation of aluminium in the ore sample? The formula employed is simple. It is given by A multiplied by B divided by W into 100 because aluminium is calculated in percentage. So A is the difference of total titer value, that is T, and sum of T1 and T2. B is the molarity of zinc solution and W is the weight of the sample taken in grams. What do you understand by CRM and SRM? CRM means certified reference material and SRM stands for standard reference material. Why it is suggested to analyze at least one SRM or CRM sample? Analyzing standard samples validates the method and the technology used. If the results obtained are in close proximity as per the reported results, it validates the reliability of the method also. Now I have taken all important questions that could be asked during your lab exam. So prepare well. All the very best. Keep watching my videos. Don't forget to like and share this video. Also subscribe to my channel. For all important links of other relevant videos related to this topic, please see in the description box. Take care of yourself and bye.